Good evening, and welcome back for the final 2012 installment of Science and Society Global Challenges. My name is Pete Folger. I'm with Georgetown University. And this program of moderator-led policy discussions uses neither PowerPoint nor notes, and is sponsored by the Georgetown University Science in the Public Interest Program, the American Association for the Advancement of Science, and the American Chemical Society. And we also warmly thank ExxonMobil for their continued support. Now, I mentioned no notes and no PowerPoint. I have notes, and there actually will be a couple PowerPoint slides, but the organizers take the blame for that. Don't blame our panelists and our moderator. They'll remain pure. So I'm pleased to introduce tonight's discussion. It was originally scheduled, as you may know, for October 29th, but was delayed due to the arrival of Hurricane Sandy. Tonight's discussion is called Climate Change, the Arctic as an Emerging Market. And our panelists are Julianne Struve, Jed Hamilton, and Heather Conley. Moderating the discussion is Richard Harris, who brings his crack NPR journalism skills and direct experience in this venue, and including our most recent discussion a couple of months ago, in October, on the energy, water, food nexus that some of you may have come to. Now, without further delay, although I want you to turn off your cell phones or mute them, and unless we're hit by a derecho, I think we're ready to go. Richard.
Thank you very much. Welcome, one and all. We actually only have, was this a PDF or a PowerPoint? We said bring a PDF, right? So we would not violate the no PowerPoint rule, and we only have one of them. But this is, I think this will help us stay oriented throughout the day and or evening. And let me give you just a sense of what's going on. We're going to talk. I'm going to try not to talk too much. I love this topic. I could spend all hour and a half just peppering these folks with questions. But what I'd like to do is get the ball rolling with some questions that sort of set the stage. And about maybe 45 minutes in or so, then I will open it up for questions from the audience. We have a couple of microphones, and you can come to those. I sort of think of this as a slightly elongated play EP Talk of the Nation kind of format, where you can be the callers, and I'll be Neil Conan or Ira Flato, depending upon the day of the week, and we will at any rate we'll just have a lively conversation here, and looking forward to the evening. And I got to also keep track of time because I know this one's going to whiz by. But let me make some very brief introductions. Julianne Struve, right, is from National Snow and Ice Data Center and you're a research scientist there. That's at the University of Colorado in Boulder. And but it's this own sort of separate thing. If you ever want to find out about Arctic ice and you don't know about NSIDC already, it's a great website to go to. You can see just how badly it's melting at any given moment of the day, any day of the year, and it's a wonderful resource for keeping track of the Arctic ice. To her left is Jed Hamilton, who's or the senior Arctic consultant. The senior Arctic. You could have had somebody who started exactly the same day, but he's at ExxonMobil Upstream Research Company, and this is about as upstream as you can get, I think, the Arctic is. And to his left is Heather Conley, who is the director and a senior fellow at the Europe program at the Center for Strategic and International Studies. And she's obviously the policy person we'll pick on for some of the policy questions and so on. So the question really is, what's going on up there? It's a part of the world that until a few years ago we weren't thinking about, most of us. Probably most of us still aren't, but things are afoot up there. I just read that there was a liquid natural gas tanker that went from Norway to Japan through the Arctic Ocean in November. It's like, hello? Isn't that white stuff ice? So at any rate, things are changing up there rapidly, and the question is, what are the implications for global conflict, for resource development, et cetera, et cetera? So we're gonna poke and prod at that question during this conversation. And I want to start with Julianne, first of all, and say, what is going on up there? Let's start with the natural world up there. What's happening with that ice?
Well, there's several profound changes happening in the Arctic, and certainly what's become basically the poster child for climate change is the decline of the Arctic sea ice. And we have about 60 years now of pretty reliable data, a little bit more than 30 years of satellite data, but we also have earlier observations from ship reports and aircraft. So we can kind of go back to about 1953 pretty reliably. And during that time, we've seen the Arctic summer ice cover is shrinking quite dramatically, and it's been sort of this linear rate of decline, but in the last few years it's accelerated quite a bit. And it's been taking a lot of us by surprise because the changes that we're seeing in the summer ice cover are definitely outpacing a lot of what sort of our worst case climate models have been suggesting would be happening at the Arctic as we continue to warm the planet. And so these changes are happening a lot faster than we expected. And it certainly is, there's a lot of implications for that, definitely with governance and certainly exploration, because these regions of the Arctic that before were always covered by ice year-round are actually now opening up for quite a few months during the summertime. And when you look at a lot of our climate model simulations and you increase amounts of atmospheric greenhouse gases in the atmosphere, every one of those climate models suggests that as we keep doing that, the Arctic Ocean will become ice-free. And some of these models suggest it may happen as early as 2050, some of them sometime after 2100.
2015 or 50?
2050.
50.
Although I have to say there are some models that suggest it could happen as early as 2020. But when we compare the observations to a lot of these climate model simulations, we find that on average the models are still lagging the observations. And so we're probably about 20 to 30 years ahead of what a lot of the models are showing us as to when this might happen.
Yeah, and this was a banner year, for melt. But let's distinguish between summer ice and winter ice, because it's not going to be open,
right,
wide open year round. There's a natural cycle that is, I guess, gone on for a long time, right? It grows in the winter and shrinks in the summer, right?
Right, and so what we really talk about when we talk about ice-free Arctic, it's really ice-free in the summers because it's still going to get cold enough for quite some time for the winter ice cover to come back every year. And the changes in the winter ice cover are pretty small. There's definitely some more open water that we're seeing in sort of the eastern Arctic, the Kara and the Barents Seas. But most of the Arctic is still covered by sea ice in the wintertime. So we're really talking about the summer ice cover and opening up the regions off the coast of Alaska and Siberia that are now becoming ice-free.
Again, so these used to be sort of permanently covered in ice?
Right.
Yeah.
Yeah.
Wow, so big changes. So let's turn to the geopolitical implications of this, Heather. I mean, what was it, 2007, the Russians made a big deal of planting a flag in the middle of the Arctic Ocean, and it seemed as though everyone pulled out their pens and started writing stories about conflict over in the far north. Should we be worried?
Well, the Arctic has always been very important geostrategically to us. Recall in World War II, it's vital supply lines to the Soviets in the Eastern Front. Then during the Cold War, strategic bombers flew over the ice, nuclear subs under the ice. It's always been strategic. The U.S. missile defense architecture is in the Arctic, whether that's from Fort Greely, Alaska, through Thule, Greenland. The Russian strategic nuclear forces, their northern fleet, is in the Arctic. So it's always had a great deal of geostrategic importance to the world. But after the collapse of the Soviet Union, things sort of, the relationship thawed a little bit. And it became much more an area of opportunity and collaboration. And in 1996, a new organization was formed called the Arctic Council. And it brought together 8 member states, the 5 coastal states, the US, Canada, Denmark via Greenland, Norway and Russia, plus 3 other almost the coastal states, but not quite, Finland, Sweden, and Iceland. But most importantly, it brought the indigenous peoples together at the table, the permanent participants. And since 1996, that's been the primary vehicle for how we've collaborated and cooperated regionally about the Arctic. But as we're seeing the rapid thawing, other non-Arctic states are becoming very, very interested in what's going on in the Arctic. And not only this summer did we see a gas condensate go from Hammerfest, Norway to Japan, we saw a Chinese icebreaker come through the Northern Sea route. And here's your quiz. What's the largest diplomatic embassy in Iceland? China has the largest diplomatic. You're like, why would China be in Iceland? Well, a lot of rare earth minerals. They understand the strategic implications of a shortened shipping route from Asia to the West. So this is now becoming a really hot topic geoeconomically because of the fishing, because of the mineral resources, the natural resources. Ted will talk a little bit about that. And so all of a sudden, there's a global interest around the Arctic. But then I'll give you another little quiz.
Well, let me ask
Sorry,
you about
please.
that. The original question was about conflict. Let's sort of set the stage here a little bit. Should we be worried about conflict? We could talk about some of the other stuff a little bit later in, but.
No, this is our Norwegian friends who call the Arctic the high north. They say this as high north, low tension. That we aren't seeing great tension. In fact, we're seeing 2 years ago, Norway and Russia, after 40 years, agreed on their border in the Arctic. We're seeing where cooperation between nations on search and rescue, oil spill and response, they're trying to address the transformation. So I've disappointed many journalists, Richard, when I've said, we're not seeing the militarization of the Arctic. If anything, I would argue we don't have enough capability, search and rescue, icebreakers, because all of this commercial activity, all the wonderful tourists who want to go to the North Pole, they're going to need to be rescued. But we don't have the ability to rescue them right now. And my quiz is, okay, everyone, how many icebreakers are in the United States Coast Guard fleet today?
I know.
How many? That's right. You got one, and you better hope it's in the right place at the right time when you need it. So this is about developing the U.S. infrastructure, but also working very cooperatively with our partners.
Yeah. And Jed, I mean, there's another simple storyline that is I'm sure not entirely true, which is that the ice is melting and all of a sudden there's a big oil rush up there. And Shell, of course, we've heard a lot about their efforts this summer to get a foothold in the Arctic, and it's being portrayed as a brand new thing that hasn't happened before, and so on. Put that in context for us. How new is this?
Okay, Richard. Yeah. Well, the industry has been working in Arctic-like conditions since about the 1930s, when ExxonMobil started developing the Norman Wells field, which is 1 degree south of the Arctic Circle in Canada. And we put the first offshore platforms in a significant sea ice environment in Cook Inlet in the mid-60s.
Hold on, let's do a little geography here. Cook Inlet is down.
Yes, it's still what we would call, it's below
it's right here, right?
Yes.
So that's sort of out of the Arctic, but it's in cold water and it ices up, right?
Yes, and it's got high tidal current, so it was fast moving and fairly thick first year ice. And we moved through the 70s and 80s with exploration in the U.S. and Canadian Beaufort with a number of gravel islands. All the development there has been from shallow water islands, nothing exceeding really about 20 meters water depth.
So you pile, if you want to go drill offshore, you sort of build an island out of gravel, and then you can use
right,
that as
and those
your
are
foothold.
able to sustain the ice loads without a problem. There have been about 412 discoveries north of the Arctic Circle, and there are quite a bit, has been quite a bit of oil and gas development. Of course, one of the most prolific areas north of the Arctic Circle is the Yamal Peninsula in
Where's
Russia. Let's see
Help
if
me.
you can find Yamal. It's over here.
Here, let me give you the pointer. I knew I was going to get in trouble very quickly with the geography.
This is the Yamal Peninsula here, where a lot of the gas that supplies Europe comes from. And recently, ExxonMobil signed a joint venture agreement with Rosneft to develop 3 blocks in the Kara Sea, which is right here between the Yamal and this island called Novaya Zemlya. And those 3 blocks are on the order of the size of the entire productive portion of the Gulf of Mexico. So the industry has a long experience with development in Arctic conditions, both onshore and offshore. ExxonMobil and Shell both developed off the coast of Sakhalin and up to 2 meter thick first year ice, but again, it's subarctic. So now what the industry is looking at is potentially moving to what we call deeper water, which for the Gulf of Mexico would be 400 plus meters, but in the Arctic, because of the ice loads, you get to a deep water transition at about 100 meters, where if you're going to put any kind of facility out there, it has to be floating versus bottom founded.
Yeah.
Because of the ice. And there's probably not a lot of conflict over that whole middle part of the Arctic Ocean, because that abyssal plain has very thin sediment cover, and at least from a hydrocarbon perspective, it wouldn't support any oil or gas. So once you get too far off the shelf there, it's pretty barren.
I see. Yeah, I want to talk about the shelf because there's some weird politics and so on with the fact that there's the 200-mile zone limit and so on we can do with that. But I guess in terms of oil exploration up there, I mean, Shell says, well, it's at least where they're drilling in the Beaufort and Chukchi. You want to show people where those are? Yeah. They say, you know, it's second only to the Gulf of Mexico. And some people say, well, why not go to the Gulf of Mexico Beaufort, where you can... That's the Chukchi is closer to Russia than the Beaufort's a little
They're
bit.
over here, and Beaufort, they're here.
Yeah.
Both of those are in less than 100-meter water depth.
Yeah, but yeah. But I guess the question is, why so much interest up there? I mean, are we really running that low of resources in places that are easier to get to, easier to cope with if there's a spill and so on?
Yeah, well, a lot of people reckon that by 2030, the current demand for hydrocarbons will have increased by 50%, with hundreds of millions of people in countries like India and China just now becoming large energy consumers. And when you look at the suite of opportunities around the world for trying to meet those energy demands, it's going to take everything that's available. And the Arctic is one component of that. The USGS has reckoned that about a quarter of the remaining undiscovered hydrocarbon potential of the Earth lies in the Arctic. Albeit, if you look at those 400 discoveries, it follows a pretty similar trend even as you move up in reservoir size, that about 80% of those are gas and about 20% oil. Of course, Prudhoe Bay, the largest discovery in the United States, in North America, is located in the Arctic at 13 billion barrels recoverable. But the Arctic appears to be largely gas, and that gas is going to be challenged to come to market in the near term. So what we're
because
really
of cheap prices and it's hard to move stuff around, right? Both reasons, yeah.
Yeah. Well, logistically, the Arctic's very challenged, but it is a possible player and will be a player in supplying world energy demand. And it will come on as market and price conditions and our ability to do it technically come on.
Yeah, so Julian, let me ask you, how much is the ice going to cooperate with this? I mean, this year we saw it was the lowest ice in the satellite record, really incredibly low ice. But Shell was saying, we can't go in when we want to because there's ice here. It seems it was perhaps a little bit of irony that they were having trouble, among other reasons, getting to where they wanted to drill, partly because the ice wasn't cooperating with them.
Yeah, and you know, it's interesting. So in the 90s, if you had a low sea ice year, it tended to be either on the Eurasian sector, so off the coast of Siberia, or conversely, it'd be over on the Alaska side in the Beaufort or the Chukchi Sea. So you'd either have more ice than normal on one side and less ice than normal on the other side. And that's sort of what the 1990s looked like. This last decade, you're seeing the ice pulling back from both shorelines. So when we were looking at these new sort of record low sea ice amounts, they're encompassing both the Alaskan sector and the Siberian sector. And that's changed in the last few years. So both of those regions are opening up. But the one region of the Arctic where there's a slight positive trend in sea ice is actually in the Bering Sea. So if you point to the Bering, right, so that region right now, actually even today, is above normal in terms of the amount of ice in the Bering. And so if that takes a little bit longer to melt out in the summertime, which is sort of how you get into the Chukchi anyways, and that was keeping some of that ice around, that was part of the issue this year for Shell. But you also have this Beaufort gyre, this clockwise circulation that brings the thick ice that's north of Greenland and the Canadian archipelago up through the Beaufort and the Chukchi Seas, and it recirculates it back into the central Arctic. And so during winter, depending on the strength of the Beaufort gyre, you're going to have more and more old ice that's brought up into that region. And that old ice is thicker, and it takes longer to melt out in summer. So what we also had this summer was some remnants of some old ice in the Chukchi Sea, some old thick ice, that just took longer to melt out this summer. So it delayed when they could get in there.
Yeah, but is it fairly predictable? Because I mean, I guess what you need to do is move quickly when it's thawed, and do as much as you can, and then get out of the way before the ice comes back, right? Can you guys?
Well, I mean, so when we look at
happen?
these future projections and we force our climate models with greenhouse gases, and we all see the sea ice going down, we also have to admit that there's a lot of natural climate variability in the system. And so the year-to-year variability, I mean, you might have this trend towards less and less sea ice and eventually an ice-free Arctic. But on top of that, you have all these ups and downs, and that's the weather. and you can't predict the weather. So you might have a year with above normal ice conditions in a region, and then the next year it'd be way below. Even though as a whole the Arctic ice keeps shrinking in size, there's going to be a lot of regional variability, and I think that that would make it a little bit difficult for planning.
Yeah, that's right. If you look at Shell, and they do the same thing we do, they've looked at the past 3 decades of ice cover, and there was less than a 1 in 10 chance that they would be displaced by ice late in the summer this year, and they were, and that's interannual variability. Mm-hmm. We look in the Canadian Beaufort where we've got and we try to drill exploration wells during the open water season, and we reckon it'll take 3 seasons to drill a single well. So you have to come back each summer like Shell is doing there. And we have an average 8-week open water period, but we know quite well that over the last 35 years, there's been probably 5 years where it was 0, and a number of years where it might have been as much as 16 weeks. So it's a little bit of roll of the dice. Probabilistically, you can say, we'll do this in 2 years or 3 years, but the interannual variability will tell you when you get there, and it got Shell this summer.
Right. So how do we operate through the winter then? I mean, let's say you get a producing well going. How do you prevent it from getting clobbered by icebergs or whatever?
Yeah, well, in the subarctic locations or in the Arctic shallow water, you just put up a bottom-founded structure that's robust enough to resist the ice loads. We've done that off Sakhalin Island. There are the gravel islands up off the Alaskan Beaufort Sea there, which can resist the multi-year ice loads, which are the real significant ones. So we have the technology and the experience and have done it in the past to put bottom-founded platforms up to a water depth of about 100 meters. Beyond that, now you're talking about platforms that are as big as Reliance Stadium in Houston, and there's no graving dock in the world to build anything any larger. They're difficult, if not impossible, to tow out through the Bering Strait or Kara Gate. So there are water depth limitations. So it is a physical limit at about 100 meters. Beyond that, we're floating, and that's the technology that we're working on now.
Would you eventually have pipes just running along the seafloor so you don't have to have structures at the surface once you have a producing well, or would you always need something at the surface?
Well, no, you can have what we call subsea development, where all the production facilities and maybe even compression and the water separation and reinjection is all subsea. It's all lying on the seafloor, and therefore you don't have to resist the surface ice. But the kicker to that is that you've got to drill development wells. And I said, we'll drill an exploration well in the Canadian Beaufort and take 3 seasons. Well, for an Arctic development to be economic, it's going to have to be probably bigger than 1 billion barrels, which would take 50 or more development wells. And you can't drill one every 2 years, or you're drilling for 100 years. So it's the drilling of the wells that will require floaters. At this point, there's no technology for drilling from subsea. But we could develop it subsea and either shuttle tanker it out or pipeline it back to shore with a deeply buried pipeline.
Heather, let me ask you about this variability, the ice weather, if you will. How much does that affect? I mean, people are talking about, you mentioned fishing and shipping across the Arctic. How much can people sort of plan up to do that if there may be years where they're just essentially frozen out? Does it matter, or how does that play out?
Well, it does, and I think it impacts, it's certainly U.S., 50% of American fisheries come from Alaska. It's a huge source of fisheries also for Russia and for Norway. This is major money for their economies. We don't have, I don't think, clear scientific data, but there's sort of an assumption that as the water's warm, the fishing stocks may go north, may have a variation in their patterns, and people are very concerned about what that means. Could we potentially have some conflict between 2 fishing trawlers that have decided that this fishing stock was really theirs, it just moved, and of course illegal fisheries as well. So we're also seeing increase in cruise ships going and expeditionary going to the North Pole, in fact, and we're still trying to grapple with what are the best policies. The Greenlanders have this very new approach where they only allow 2 cruise ships to go up along their coast in tandem. And you're like, well, why is that? Well, if they hit something and they have to be evacuated, there's no place to evacuate could be 400, 500 people, immediately they have to have that ship as an emergency evacuation. But that's not standard practice anywhere. They just sort of, well, that's the rule if you want to go for Greenland. So we don't have any standardization of this. Or you think about an oil tanker or shipping cargo. The International Maritime Organization has a polar code, how you have to build strong, durable ships. But it's voluntary. It's not mandatory. How do you start requiring the best practices for shipping? So in some ways, I think the governance is trying to catch up with the transformation that's happening, and with best intentions, and it's moving rapidly. It may not be moving rapidly enough. So it's keeping the good science with good balanced economic development, but making sure we have the infrastructure and capabilities to get it right. So we're just going to be testing the system across the Arctic and testing the international cooperation and the systems that we have to make sure we can work together and not at cross purposes.
Yeah. And you mentioned that the U.S. Coast Guard only has a single icebreaker. How seriously are we taking the need to have more capability to get up there? And what about Canada and Norway and Russia? Surely they do better than that.
Well, Russia has 25 icebreakers, if we're comparing ourselves. What we've done in the past, and certainly the National Science Foundation has done, is we borrow some icebreakers. Recently, we had borrowed a Swedish icebreaker to help resupply Mercado Station. But sometimes the countries need them back, and the ice was pretty significant in the Baltic Sea, so our Swedish colleagues said, sorry, we need the Odin back. We can't help you with that. Oops, now how are we going to do that? We can rely on Russian commercial icebreakers. It is a big issue, and the U.S. government has been really grappling with it because we haven't built an icebreaker in over 30 years. It's going to cost an extraordinary amount of money, estimates of $1 billion for one icebreaker, and it would take probably 10 years for that procurement cycle to actually have a product ready.
But we do have one that's sort of in service in Seattle, right? That's being fixed up, don't we?
Well, yes. The motor's being rehabbed. We hope it's online by next year. But the question is, we're trying to answer an infrastructure question, but I don't think we've sort of have a strategy, an agreed to national plan. How much are we going to develop the Arctic? Or how much are we going to protect it? And you sort of have to build your infrastructure plan, whether that's icebreakers, airports, civilian search and rescue capabilities, to what you think how much you're going to develop and do this. So as a nation, we need to sort of put forward our vision for the Arctic. It's got to be a longer-term vision, and this is where the difficult part is. It's going to take resources to do that, but we often, I think, have a fallback when a crisis happens. Heaven forbid, an incident happens in the Arctic, then we will find the resources, we will rush, but we aren't able to think it through and then build in the multi-year budgets and the resources to make it happen. And of all the crises that we see around the world globally, it is very hard to make the argument that we need to put that money right now for something that seems like it's going to be a 20-year problem or a 30-year problem.
Well, Jed, if you were on a government panel advising them how much to build up this infrastructure, what would you say? I think from the standpoint of oil development on this coast of Alaska, I think the closest Coast Guard station is down here, and it's like a 1,000-mile trip around. It's not terribly convenient, but what do you think is the right level of resources up there?
Well, the oil companies provide the fleet that we need from the commercial stocks of vessels. For instance, Shell had, in addition to their 2 drilling vessels this summer, a fleet of 20 additional vessels, and they had used both of the Finnish icebreakers, the Finnica and the Nordica. So when you look at what industry is going to do, in the year 2014, we'll be drilling in the Kara Sea. Shell will presumably be back out in the Chukchi and Beaufort, and there will be drilling in the Baffin Bay area in the northwest part of Greenland. All those will require icebreakers, and they'll primarily be commercial icebreakers, and it'll put a real strain on the ice-breaking fleet. I mean, we're looking to contract vessels now. But when you talk about the things where a government gets involved with search and rescue and oil spill response and things like that, then I would think the government does need their fleet. However, we always assume that whatever we will need, we will supply. And that goes for oil spill response vessels, icebreakers, search and rescue vessels, everything.
Yeah. Well, if you have an oil spill, you are, at least in U.S. waters, you are the responsible party, and the Coast Guard. I mean, the American public expects the Coast Guard to be there, but it's not the Coast Guard's job to clean it up, right? It's whoever spilled it is supposed to clean it up, right?
Right, but the public does have an expectation that the Coast Guard will assume a significant role in directing the cleanup. They're not responsible financially or anything, but and so there are precious few vessels in the U.S. Now, other countries have quite a bit.
Let's move on to land for just a few minutes, and I can come back to you and ask you. I think the other record that has been set is record low Northern Hemisphere snowfall, right? And what implications does that have for lots of things around the Arctic? I mean, is the ground turning all spongy?
Well, so, I mean, the record low in snowfall is really happening sort of spring and summer. So one of the things that we're seeing, for example, with the loss of sea ice, you have a lot more water vapor in the Arctic atmosphere, say in the autumn and the winter time. And so interestingly enough, you seem to be getting a little bit more snowfall early on in the season in places like Siberia and parts of Eurasia, just from the Arctic holding a lot more water vapor, and that's falling then as snow. But as we keep warming, what's really been happening with the spring snowpack is that there's been a stronger decline actually now in the spring snow cover than we're seeing in the sea ice. And so when we think about the importance of why snow and ice matters, one of the biggest reasons is that snow and ice is highly reflective. It reflects most of the sun's energy back out to space. It helps to keep the planet cool. So if you're reducing the amount of snow on land, for example, then you're warming up the land faster. You're warming up the land then surrounding the ocean faster as well, which can then maybe help the melt happening faster with the sea ice earlier in the melt season, things like that. So it's sort of these positive feedback effects when you take away the snow early, you're warming it up quicker, you're melting the sea ice then earlier, and you're exposing more of the dark ocean, which then warms up even further, melts more ice. And so you sort of get this positive feedback, which is amplifying the warming in the Arctic. And so when we look at these sort of projections as to how much the planet's going to warm, maybe 2 degrees by the end of the century, when we look at the warming, for example, in the Arctic, it's going to be probably 3 to 4 times that. And one of the things that's important with that is I just saw a recent update, for example, on how much carbon is stored in the frozen land, frozen ground up in the Arctic. And it's now been estimated at 1.9 trillion metric tons. And so when we look at climate change, and we look at warming the Arctic more as the sea ice retreats and the snow cover retreats, all those microbes that are in the frozen ground right now start to get active, and they release more and more carbon into the atmosphere. And that's sort of this feedback that we haven't really fully taken into account in a lot of our sort of future scenarios. I mean, we look at human emissions of greenhouse gases, but there's this big looming feedback as the permafrost starts to thaw. That's going to be a really big concern, I think, in the near future for us.
Yeah. Do you think that would draw more activity, more development up to farther north? I mean, obviously it could affect us and our weather down here. What about changes in to the sort of the Arctic?
Certainly the infrastructure in the Arctic. A lot of it's built on frozen ground, the highways and the buildings, and a lot of that is starting to see some collapse, certainly as the ground keeps warming. Even, when you look at how some of these indigenous cultures, how they get around. I mean, they're traveling along on frozen riverways and different frozen lakes, and as those start to thaw more, that certainly changes their ability to access regions and transport goods and things like that. So in terms of infrastructure in the Arctic, I mean, even if you're trying to think about building a runway or you're trying to think about building sort of stations for search and rescue, you really have to think about, well, where are we going to put these? Because as the ground keeps thawing and you're losing also the sea ice, you're exposing these coastal areas to larger storms and waves. So you have a lot of coastal erosion. Yeah. And so that really comes into play when you're trying to plan for infrastructure in the Arctic.
And I think we forget, 4 million people live in the Arctic.
4 million?
4 million.
Not in Alaska.
The coastal, not just Alaska, but Russia, obviously, but all the coastal states. And you talk about the permafrost thaw in Russia. You're seeing, where pipelines are cracking, buildings are, literally they're sinking because of the thaw of the permafrost. And you're absolutely right, infrastructure. Most of our infrastructure, quite frankly, in Alaska, from hangars to airports, is from the dew line, from President Eisenhower and the distant early warning system. That's what's left. It's rusting. It's not in great condition. And absolutely, it's sort of a question of how much you want to do. For instance, when you look at Barrow, Alaska, if there was an emergency or some major operation, they have 30 beds in Barrow. When you think of a major oil spill response or a major search and rescue, a mass casualty issue, you talk about if you need it, you bring it with you. There's not housing for rescue workers and for triage and things like that. So it's a massive, undertaking to think how we, the U.S., can be prepared, and how we internationally, working with our Arctic partners, how we can together be as prepared as possible should a mass event happen.
Yeah. Jed, so what is the story with the oil companies on this? How are you thinking about melting permafrost and so on?
Well, I'll start with sea ice and then go to permafrost. We're not making a push towards the Arctic now. Of course, we've been doing it for years, but you see a lot in the press now. We're not making that push because of receding summer ice extent. We have to design facilities to put out there all year, and there are plenty of what we call freezing degree days, which is the number of degrees below zero times the number of days, to build up thick first-year ice in the wintertime to 2 meters thick, and we have to contend with that. So that will always be there regardless. With regard to permafrost, where we are doing onshore developments, say Point Thompson, we do have to take consideration of permafrost for foundations, and of course we insulate the wells, and in some cases there's passive cooling to keep them from melting the permafrost, so we don't have subsidence issues.
So you actually refrigerate in the Arctic?
It's one of our crowning scientific achievements at ExxonMobil, for which NASA gave us an award for the use of NASA technology, was when we built the Trans-Alaska Pipeline. All that above ground section, and a lot of it was above ground because of to mitigate potential earthquake damage. All those supports are on piles that go into the permafrost, and they have a passive cooling system that's completely contained and based on ammonia that uses the ambient air temperature to keep the permafrost frozen to offset the pipeline temperatures so that we don't melt the permafrost.
So you basically, if you can think ahead, you can keep ahead of permafrost melting with technology, or not? At some point, do you realize you're wading through muck with wader boots?
Well, locally, I guess you can artificially maintain it, but not over a wide scale.
Yeah. Is that a big concern when you think about exploiting more Arctic oil and gas resources?
Well, certainly the winter season and generally your construction season onshore, as just diametrically opposed to offshore. Your construction season onshore is in the winter when you can build ice roads, and the state of Alaska has to certify when the tundra can be operated on, and that operating season in the winter has shrunk significantly, both from warming temperatures and from them being more conservative in their criteria, not wanting to damage the tundra. So yeah, it has an impact on what you can do and how much you can do in a single season.
And Heather, I also wanted to ask you about other resources up there on the land. There's a lot of timber. There's a diamond mine, isn't there, up in Canada? What kind of other resources are there? We think of just oil and maybe a little bit of fish, although I think most of the fish are not really in the Arctic Ocean, right?
Right.
Yeah.
I think obviously a lot of the attention has been focused on the oil and gas and the potential that is there. I think in the near term, it's actually going to be the mineral resources that may have a more immediate impact, and that's not only the rare earth mineral potential in Greenland, Iceland, but you're seeing where the world's second largest zinc mine is in Alaska, Red Dog mine, and you have iron ore, Baffin Bay, nickel, palladium, uranium, Russian mines. These are truly 21st century minerals that we need for our cell phone and technology, and they in some ways are pulling a lot of mining interests. They've been well established, they've been there for decades, but now really going full scale. And I think mineral resources, you mentioned diamonds, but again, I think rare earths will take a more prominent role as we see Arctic development, absolutely.
And do they need ocean access to get that stuff out, or are there other ways to bring things out of the Arctic?
Well, I mean, you certainly will see an increase, and this is particularly over Russia, either the Northeast Passage or the North Sea route. What we're seeing is a much greater drive for what we call destination shipping, going up, getting those resources and bringing them back to market, less so than transit shipment, which is going through the Northern Sea route, west to east or vice versa. And I think this will continue to be a growing issue. I know in Canada, there's some concerns in the Northern Territories, Nunavut and others. Again, how do you balance between wanting to access that economic development with Indigenous peoples and their control over that? And again, I think we have to pull back and understand there are people whose lives, food security, are being deeply impacted by this transformation. This affects societies, it affects ways of life. And so again, it's finding that balance between the economic development and getting those needed resources and jobs and economic growth, balancing that with sustainable development, a sustainable approach. Now, as a diplomat, when you find that balance, it means that both sides hate it, because both sides don't want you doing what the other one is doing. But that's the balance that we have to find, I think, in the Arctic. Some countries are going to be more focused on the economic development. Some countries are going to focus more on preservation and protection, but finding that balance. But these resources, the mineral resources, the oil and gas, fisheries, again, and that tourism, which just means a lot of tourists and adventuresome tourists that want to, sail through the Northwest Passage and, have to be the first one up to that North Pole. We are going to be finding more and more assets are going to be needed to get them back home, and that will be challenging and stretching our resources.
Yeah. Let me interrupt for 1 second just to say I'm going to start opening the mic for questions. So if you have a question, you please come up to a microphone here and Jed, go ahead.
Oh, I was just going to say the reason the Russians have 25 icebreakers and they have the nuclear icebreaker fleet is because they've been moving cargo and ore, North nickel, from Murmansk through the Karagate over into the Yenisei River for decades. And so they have a significant fleet, and they go year-round through the ice. And matter of fact, we have put some Russian Arctic and Antarctic Research Institute scientists, along with our own Exxon people, on some of those North nickel voyages to study the ice conditions in the Kara Sea during the winter.
But one thing to think about when you look at the Russian Arctic, think about our Mississippi River and sort of the Mississippi Delta upside down. So that's sort of pointing north towards the Arctic, a major river system where, unfortunately, as the permafrost is occurring, a lot of environmental degradation is now thawing, seeping, and going into coastal areas, and we think greater ocean acidification. So all of these systems are working, unfortunately not in a helpful way, working together as we see, but so much industrial development in the Russian Arctic, and you mentioned Nova Zemlya as one of the places. I mean, it has been a nuclear test ground since the Cold War, so lots of very interesting things will also be found as the melting occurs, and I don't mean interesting in the good way.
And Julian, are people calling you and saying, or do you have a sense of sort of what future endeavors are percolating from people sort of curious to really understand better what's happening with the ice? Or are you just more focused on just the satellite imagery and all the rest of that stuff?
Well, my research is actually getting more interested in sort of the impacts of why does it matter if we lose the sea ice? So I'm much more interested in the climate impacts, because it's one thing to talk about what's happening up in the Arctic, and as you pointed out, there's a lot of people that depend on the sea ice for their survival, for example, and a lot of species as well. But to get people down here to be concerned about it, you need to bring some more relevance to them. I mean, they might think, well, I'm sad about the polar bear if that goes extinct, but it's not enough to really, I think, motivate people to do anything about it. So I think a lot of the science now needs to go into, what are the climate impacts for the rest of us? How is it going to impact storms, for example, in the lower latitudes? And so, and of course, that's not an easy thing to try to figure out, because while we can understand some of the physics and how warming the Arctic is going to change sort of the large-scale weather patterns, for example, and we find these correlations between them, there's also so many other things happening in the climate system at the same time, so it's really hard to isolate. Can you say, did Hurricane Sandy happen because the Arctic had a record low sea ice year, for example? Those dots are hard to connect, but I think that's the direction that the science really needs to go into, is to bring some of that relevance home.
Yeah, and I guess some of it comes down to the moisture you mentioned. If there's more moisture in the air above the Arctic, you get that can influence weather patterns far away, right?
Yeah, and one of the things that we've seen following years with less sea ice is actually getting stronger cyclones and more frequent cyclones, for example, in the North Atlantic region, tracking up through the Kara and the Barents Sea and then dumping precipitation over parts of Siberia and Eurasia. So that's one of the things that we've noticed. And certainly by warming up the Arctic, you're changing the difference in the temperatures between the Arctic and the equator. And that's what drives a lot of your large-scale atmospheric and ocean circulation. So you're weakening, in some ways, you're weakening some of the wind speeds that bring these weather systems up. And we've been noticing that by warming up the Arctic, that we actually are allowing sort of extreme conditions to persist longer, so droughts or floods, they're moving slower in the atmosphere so they can stay around in a region for longer and cause more extreme events.
To what extent is operating up in the Arctic affecting this? I mean, vessels put soot in the air, soot falls on ice, it makes it dark, it makes it melt faster. Is that a big effect or a little effect?
You know, there hasn't really been any studies that have quantified that yet. I mean, part of it is, of course, the difficulty in trying to measure how much soot is up on the snow and the ice. I saw something actually just today where people are trying to think about trying to limit the amount of aircraft, for example, flying over the Arctic, because they think it's depositing a bunch of soot, for example, on Greenland, which is causing more melting of the ice sheet. But there's not really been any, I think, quantitative work really done to look at the Arctic as a whole and how much black carbon are we actually putting onto the ice that's accelerating the melt. I think that's a study we need to do, and even looking at the impact of icebreakers, for example, and all of the ships that are up there now. I mean, one, they're putting more soot in the atmosphere that's falling on the snow and the ice, but they're also opening up open water areas within the ice and opening up.
That makes it darker and makes
and absorbs more of a sun's energy. And I don't think anybody's done those studies yet.
I guess at least some of the Russian icebreakers are nuclear, so they're at least not putting out soot, right?
Right.
But yeah. Do we have questions? Please introduce yourself and ask a succinct question.
Hi, my name is John Gardenier. I'm a retiree from the Federal Service and now mainly dealing with ethical issues in science. And in that regard, I'm curious about the feedback loops for the two ladies to address between geology and population dynamics. I think the discussion here, very reasonably, considering the economic impacts, is focused on the next 10 to 15 years. I'm more concerned about now to 2040, 2040 to 2070, 2070 to the end of the century. Over that period, we know there will be vast melting of Greenland glaciers. Some of the West Antarctic ice sheet will get into the water. Water levels will rise. Huge numbers of populations in the tens or hundreds of millions will be displaced. They have to go someplace. Meanwhile, economically, this is going to become a more and more interesting area for people to move toward. But I don't know to what extent people displaced from Oceania and Bangladesh and like that are going to be interested in going to the Arctic, or whether people will just kind of slide up, making room for the people from the warm climes. But as that happens, that is going to change the geology itself. That will in itself have impacts on the warming. So from that point of view, I worry about the melting of the permafrost and the release of the methane trapped there, which could accelerate the global warming.
Yeah,
so
let's get it.
If the two ladies could, to some extent, address the feedback loops involved in now to the rest of the century.
Really, you got to take that one first.
You could take that, and maybe you could start by just reminding us that there's a difference between melting Arctic sea ice and melting ice that's sitting on the ground in Greenland, right?
Right. So when you're melting the sea ice, it's like an ice cube in a glass of water. So when you melt the sea ice, it doesn't actually raise the sea level at all. It's the sea level rise that we're talking about in these future projections is coming from the ice sheets and the glaciers on land. So that's where the sea level rise is going to be coming from. And while taking away the sea ice doesn't necessarily raise sea levels, In some ways, it's an indirect impact because by removing the reflective cover of the sea ice, you're warming up the Arctic even faster. And so then that can start impacting on the glaciers up in the Arctic and the ice sheet, for example, Greenland, which, if you were to melt all of Greenland, you would raise global sea levels by about 30 feet. Now, we don't expect that to happen, by the end of the century, but certainly some of these projections range from, maybe, several inches to maybe up to almost 10 feet of sea level rise by the end of the century. There's a bunch of different scenarios, and a lot of it depends on how these ice sheets are going to respond. I think scientists thought for a long time that the great ice sheets responded really, really slowly to climate change, and we didn't expect to see sort of these rapid melting events that we've been seeing more and faster discharge of some of the outlet glaciers, for example, in Greenland. So they are responding faster than we expected, and there's been a big rush to try to catch up with the science of trying to understand all the mechanisms responsible for iceberg calving, for example. What causes these outlet glaciers to speed up and accelerate and dump more ice in the ocean, for example. Where does the water go on the surface of the ice sheet and it percolates down and lubricate the bed and things like that. So a lot of the projections as to what's going to happen with sea level, I would say in some ways in terms of the ice sheet response is still a little bit premature because there's a lot I think the scientists still don't fully understand about the mechanisms that are controlling the amount that the ice sheets are contributing to sea level rise now. We know that they are contributing, but how they're going to keep responding in the future is a bit unclear.
Yeah, and Heather, I know there's a fair literature on what global warming in general means in terms of conflict, maybe not Arctic focused in particular, but maybe you could say a word or two about that.
It's interesting. I think, in the near term, we're seeing, I think, some very interesting sort of geopolitical migrations. So, for instance, a year ago, the first mosque was built in the Arctic Circle, the Russian Arctic Circle, and that was because Central Asian migrants needed to work the nickel mines and the iron ore mines, and they were pulling that migration up. We're going to see, potentially in Greenland, probably a workforce of Chinese workers that may be larger than the population of Greenland of 57,000 people. Now that will have a cultural dynamic, a political dynamic, an economic dynamic that's very different than what we've seen and will challenge those countries potentially as well. So we're already seeing, I think, some changes and some adaptation just in sort of the physical migration of peoples. Yeah, absolutely, the geopolitics of climate change and obviously the international conferences that have been going on. It's the question, obviously, of the transfer of wealth between wealthier nations and those nations that will feel the unfortunate impact of climate change more greatly. And there's a big disagreement about how that that transfer of payments will go. How do we prepare these societies for the changes that are coming? And then how do we get the developed countries to reduce emissions and keep, any rise of global temperature change beyond 2%? 2 degrees Celsius. These are very, very big challenges, and while we're talking about them, my own sense in dealing with the Arctic is we're focusing probably more on how to handle the change than dealing with that impact of how to stop that change. And I don't know whether this is some early recognition that we're hitting that turning point. And Julian, I don't know whether it's, everyone talks about this inflection point where we're already past the ability, that feedback loop's already started, or can we stop and roll back, maybe refreeze the Arctic as you're doing, Jed. But where are we politically to make that happen? I think those are huge and very unresolved questions for a decade or more.
We have a question over here.
Hi, thanks for coming today. I'm a graduate student at Georgetown University, and I'm originally from Alaska. And I was glad to see this event organized. My previous job working for the Alaska State Legislature, I felt like we were the only ones talking about this. And all of our budget committee meetings and resources committee meetings were all focused on this, and it's nice to see that it's happening outside of Alaska as well. My question is regarding the law of the sea, and I don't know who would want to answer this. What are the ramifications for the United States failing to ratify the law of the sea?
Well, first of all, would you like to define what the law of the sea treaty is?
Bless you for the question. Yes. The United Nations Convention on the Law of the Sea was negotiated in 1982. It basically is the international rules for oceans and seas, and it helps countries with international law on your coastal area, 12 nautical nautical miles. That's your territory. It extends that for every coastal country to 200 nautical miles. It has regulations for seabed and how to mine those resources, Seabed Mineral Authority, and it's a very complex instrument. 161 countries have ratified this. The European Union is not a country, but as an international organization, ratified it. The United States has not. It has gone before and been approved by the Senate Foreign Relations Committee in the last 7 years, 3 times, I think, 2005, 2007. And the administration, the Obama administration, made a huge push just a few months ago. Secretaries Clinton and Panetta spoke about the need for the U.S. to ratify this. The chairman of the Joint Chiefs has spoken out that this needs to be ratified to ensure freedom of navigation for U.S. and protection of our important sea lanes. The Commandant of the Coast Guard has sought this. The private sector, seeking benefit there. But it's gotten stuck. In part, got too close to our election. It's not that I think the law of the sea causes the problem, but there are some technical concerns that senators do have about the treaty that date back to President Reagan's time. But I think the real problem is the first 2 words in front of it, United Nations. And that, as we just saw this week with the Treaty on UN Convention on Disabilities, there is something very deep-seated and concern about the United States giving sovereignty to the UN in this regard. And I think over these last 3 decades, we've gotten pretty good at saying, but we treat the law of the sea as international customary law. That's our practice. So we're fine. We follow those rules, but we don't have to, what are we going to hurt if we have to go through the ratification?
Yeah. So, Jed, does it matter to you whether this treaty gets ratified or not? Or your company?
Well, you probably have to let someone at ExxonMobil who deals with that speak to that, because I'm a researcher, and I'm on the technical side.
If it helps, the American Petroleum Institute it's been very supportive of the law of the sea.
So what implications would it have for oil and gas development, for example?
Well, I think that for the application for the Arctic, in addition to wanting to be able to deal with issues in the South China Sea about who owns what, and it helps to not cause conflict, but it provides a mechanism for countries to come to agreement on their demarcation of their borders. One thing it does for us, when you ratify the treaty, you get to submit scientific claims to it's called Article 76 Committee. It's a committee that examines scientific data to see whether a country can extend their outer continental shelf. But you can only start submitting that data if you've ratified. Well, countries, I assure you, are submitting data for the Arctic. Russia submitted their first round of data in 2001. They'll do it again, if not at the end of this year, beginning of next. Denmark has submitted their extension, or will be next year. But the U.S. can't. Now, we've worked with Canada to accumulate the data, but we can't submit it because, and we could potentially extend our outer continental shelf off the shore of Alaska 600 nautical miles.
So the deal is the
protect it or to explore it, or but we can't do that because we haven't ratified the.
And the deal is there's a 200-mile limit that exists, but if you're on the continental shelf, you could argue that that's still part of your continent, and so the 200-mile limit doesn't apply. But you have to make a good geological argument,
right? There's scientific data, that extends that, and the Lamonsoff Ridge, which I'm not sure we can do justice there, which is basically this main ridge, sort of the Norway, Greenland.
Use the pointer?
No, just do your best. Maybe you know where the Lamonsoff Ridge is there. That goes all the way up to the North Pole, and that's part of the Russian claim right now. So if you can imagine, it's unclear whether this will happen or not, that a country can prove that data, what a bonanza potentially for exploration. But we will be left behind because we're not putting that forward. But I think that there's a larger question of American leadership, and it just doesn't pertain to the Arctic. But when it comes to the South China Sea and the island disputes that they're hearing now, it's hard for America to exert its leadership when everybody else has signed the treaty, but we have not.
Okay, let's take another question.
Hi, I'm Saskia Demelka. I'm a reporter with the PBS NewsHour. I'm curious how this is changing the conversation between scientists and industry stakeholders. Jed, you mentioned that you're not doing this push because of the decrease in sea ice extent, but that has to be part of the big equation. Do you internally have modelers that are trying to see what this long-term, what the long-term goals are going to be or outlooks are going to be? Is there more of a conversation between climate scientists and the industry stakeholders, or interest from the scientists and piggybacking? If you're going to be going up there, we can do more observations. How is that relationship?
Yes, I mean, we're interested, and before this started, I was telling Julian that in 2007, following the previous minimum ice extent, a mid-ocean specialist, a colleague of mine, and I went and visited national experts on climate, especially as it relates to ice extent, and we visited David Thompson, who named the Arctic Oscillation. We couldn't get Julian when we made our trip to Denver, but she was very high on the list because she's probably the most published person in this area. And we visited James Overland at NOAA and Ignatius Rigger at the University of Washington Applied Physics Institute and tried to understand. But the thing that we realize is that regardless of what happens with summer sea ice extent, we still have to deal with the significant winter ice, and it doesn't really change things from an infrastructure and logistics point of view very significantly. We're interested in resources around the world because the world has a very insatiable demand for energy. I put that in perspective so people can understand. Right now, we are just developing the Hebron field, which is 1 billion barrels off the northeast coast of Canada. It'll take us 5 years and north of $10 billion to develop that field, and we'll produce it over the next 40 years before we extract that 1 billion barrels. And when all is said and done, and people have spent their entire career on that project, that 40 years of production will satisfy 12 days of world demand right now. And so that's what makes us look.
Maybe we should think of something other than oil. No. Julian, do you get people from industry calling and talking to you? And if you do, you must have some mixed feelings about that, because you're considering your concern about the buildup of carbon dioxide in the atmosphere.
Yeah, I've done some collaboration with Chevron and Statoil Hydro. The Chevron was more, they have this sort of global climate change program, and they like to get scientists to come and talk to them about what's going on with the ice cover. And Statoil Hydro was interested in some of the future projections of what the ice cover might be doing in their lease areas that they were interested in. So yeah, it's a little bit strange in some ways to do some of that, because certainly extracting more fossil fuels and putting more carbon in the atmosphere is going to just continue this trend that we're seeing and losing the Arctic sea ice and changing our climate so dramatically. So, but I also look at it that it's really important, I think, for industry to understand exactly what's happening with the ice cover and to really understand sort of the consequences and the fact that there is so much variability. And when you're trying to plan on when you're going to be drilling, I mean, you can't plan the weather. And you're always going to run into these problems. And even though, yeah, the Arctic is going to have less and less ice, as you mentioned, you're still going to have the winter ice for a long time to deal with. And one of the things that I think is going to become a big problem for some of the industry developments is that as you move to more seasonal ice cover, so you just have that winter ice that grows, and that ice is actually more mobile. It ridges and rafts a lot easier. So some of these pressure ridges and deformities that you're going to be getting in the ice will actually pose to be more hazardous than some of the moltier ice that you're already dealing with, because it's a lot more mobile. It's going to move a lot faster. We're seeing that increase in drift speed of the ice. And so some of these hazards, I think, will actually get worse for some of the development that you're looking at.
And I was actually up in Anchorage this past summer and was talking to the Shell people, and they have a whole ice war room up there. They assert that at least for the Chukchi and Beaufort Seas, where they're interested, that they have more detailed ice models than NSIDC does for this pocket that they're really interested in. So I think I imagine Exxon also has ice people too, but it was interesting to see that Shell had this collection of people who knew all about sea ice and were modeling it and staring at screens and
well, it was interesting this year
downloading your data, I'm sure, and reanalyzing
one of Ken Salazar's aide called us to talk about, because Shell's scientists were telling them that, no, the Chukchi isn't going to freeze up until December, so they wanted to extend their lease. And so then they called and talked to me about what I thought in terms of the freeze up was going to happen in the Chukchi, and I just looked at the data and sort of gave what an average freeze up date was, and it ended up that it actually froze up about average on when it typically freezes up at the end of October, beginning of November. And so they didn't actually get their extension, because part of it is that even though their scientists were saying it wasn't going to freeze up until December, that's not actually what we're looking at in the data, and it's not actually what happened. So it's interesting.
Good to note.
Yeah.
Do we have a question over here?
Hi, my name is Kendra Zamzo. I'm a AAAS fellow, and I'm from Alaska. I've got two questions. I'll try to make them very short. One is, can you talk about the economic cost to Alaska of moving these villages in the next, say, 50 years, and who's going to cover that? And how they're doing it now. And the other is, I haven't heard anything about opening up opportunities for new renewable energy, such as geothermal or tidal, that might be coming as some of the ice melts, opening up new areas.
Oh gosh, I don't know the cost of some of the population displacement. My own sense, and I follow to some extent some of the legislative action that occurs from the Alaskan delegation, whether Senator Murkowski or Senator Begich's office, to some extent. I think there's a real push and pull right now. The state of Alaska wants to seize this opportunity. It is an opportunity for economic development, but also they understand that they will be profoundly impacted by change as well. And this has to be, this is a state and federal partnership with a lot of close cooperation with the local levels. And this is where, as I mentioned before, that budget comes into play. Who gets to pay? Is this a federal responsibility? How does the state work collaboratively across the board, whether that's in a search and rescue or economic development? And right now, I think it's been to my own perspective, it's been a difficult conversation that's happening, and I think it's unclear. Again, what I would like us to do is put forward a national strategy that looks at the longer term of how we're going to do this in partnership with the state and local level. And that's just what the U.S. is going to do. And then there's a whole international wrapped around that and how we're going to work with our partners. But it's hard to figure all of this out unless you know your plan and how you're going to move forward and the resources you're going to put forward. So whether it's population movement, it's food security for indigenous populations, it's dealing with the economic development of Alaska and how that impacts the United States or other markets. We haven't quite gotten there, but I think the state of Alaska and government officials, from the governor to the congressional delegation, have been pushing Washington to try to get some action on that. I think it's something we're going to have to follow very closely.
Yeah, if memory serves, the population of the North Slope borough, which is that area, is like 5,000 or 6,000 people, and they're not all in jeopardy, right? So we're not talking about trying to cope with Hurricane Sandy slamming into New York City. It's a much, much smaller issue. And I think it's also true that the indigenous people up there have come to rely on the revenues. Particularly if you're developed onshore, they get a nice chunk of that, and their native corporations do. And I think that, I don't know, Jed, have you interacted with native villagers up there, and what is your sense of how much they want to see you there versus want you to go away?
Well, I have not, but of course ExxonMobil does, and we don't have anything active offshore in Alaska, but we do have a share in Prudhoe, and we're developing Point Thompson, and there are significant consultations with the local indigenous communities, and you really have to tip your hat to the extent that Shell did that and tried to and did manage to accommodate all the needs for subsistence hunting. They deferred their drill spread moving out because of the late whaling season. And I am familiar with what we have done with the Inuvialuit in the Canadian Beaufort, where we're looking at potential exploration well in deep water there, with significant consultation with the indigenous people, especially the citizens of Tuktoyaktuk, which would be where a lot of the Marine base is, to make sure that as we start moving people and material out of there, we don't in any way overcome their own supply chains, and that we make sure we allow for their subsistence hunting needs. And we use a lot of those people as marine mammal observers, and they're on all the vessels because they're quite experienced with that. So there is significant consultation. I just haven't been involved with the U.S.
Yeah. And as far as developing renewables up there, I mean, I don't think anyone's an expert here on renewable energy, but I will say that I know that domestically the big problem is, of course, getting the power from where it's generated to where it needs to be used. And since there are very few consumers right up there, I think that it's probably a secondary issue. There must be a lot of wind up there, but getting the power down to us here would probably cost more than it would be worth.
Yeah, I'd say it faces the same premium we face with trying to develop oil or gas in the Arctic. It's at least 2 times as expensive, if not more, because of the logistics challenge, because the market is not where the resource is. And that would be the case for any alternative energy. We're going to need all those things, but probably the Arctic is not the place to start looking for those because transporting it to market is so difficult.
Yeah, and even natural gas, you mentioned this, but it's worth underlining a little bit that the oil still, it's easier to get it to market than natural gas. Or I think, as I recall, Alaska was fighting over whether or not to build pipelines, and with the low price of natural gas right now, it seems difficult to, I mean, the economics don't seem like developing natural gas, at least in our part of the Arctic, really makes a whole lot of sense, right?
Yeah, well, thanks to ingenuity of a lot of engineers in our industry, all this unconventional gas has become available to us. And you look at the impact of natural gas prices in the United States on a per BTU parity basis. Natural gas should cost about 1/6 per 1,000 standard cubic feet as oil costs per barrel. So at $90 a barrel oil, we would expect gas to cost 1/6 of that, which it did not very long ago. And the whole industry was focused on global movement of gas through liquefied natural gas, or LNG. And then we found out, or we perfected the ability to produce these unconventionals, and now gas is $3, so it's 5 times cheaper than oil on a per BTU basis. And really, that's been a real bonanza for the U.S. in sort of a recessionary time to have access to not only low-cost energy, but a long-term stable supply, and it's the cleanest burning source of carbon that we have.
But it also means it's certainly not cost-effective to start piping it down from the high Arctic when it's abundant, at least at the moment, appears to be.
That's right.
Here.
So we have a McKenzie gas project in Canadian North that's on hold, and we're still trying to look to bring the Prudhoe Bay gas cap down to the States, which is a tremendous source of gas, but not economic to move.
All right, more questions.
Perfect segue into my questions. My name is Bill Hersey. I teach chemistry and environmental science at American University after careers at Monsanto and EPA. But my question is, it also, natural gas puts out about half as much carbon per kilowatt hour as coal, which is another good thing. But my question is, to me, it's kind of scary to see how much capital one company and one nation is putting into developing the capacity to put more carbon into the atmosphere, when we're also talking about how are we going to adapt New York to rising sea levels? Not to mention, how are we going to adapt Miami or New Orleans or London? And my question is, at what point do we cross the line where we don't have enough capital to develop non-carbon using energy sources, and also have the capital to protect coastal areas from sea level rise? If the Greenland ice sheet goes and Antarctic ice sheets go, we're talking big bucks in terms of protecting coastal cities. And so, are we going to have enough capital left to develop alternative energy sources and enough capital to protect coastal cities? Is there a bright line where we cross where we can't pull the chestnuts out of the fire anymore?
Ted, I know you're not exactly a policy person, but I think do you want to try to nibble away at that one, or do you want to punt it over to Heather?
I'd love to punt that. But, I mean, that is a significant question, and I don't know the answer to that. I know that alternative sources of energy are being explored. I mean, ExxonMobil is looking at algal biofuels, but we also understand that it's market driven, and they have to find a competitive place in the marketplace. If you look at the world energy consumption, which I tried to give an example of how huge that is, and the monumental task of supplying that, all sources are needed, and I don't think we'll quit using energy. So I would expect the capital will be there for whatever is cost-effective sources.
I'm aware that we can look for energy demand to go up by a factor of 3 or 4 in the next 20 years. That's what I understand. And we're going to need to develop solar and wind at a much faster rate than we are now. That's just
I can offer an interesting case study, and that's the study of Germany. Following in the wake of the Fukushima nuclear incident, the government decided to go completely nuclear-free in 2023 and go to a total 100% renewable energy strategy. Now we know German manufacturing is very energy dependent, all those wonderful BMWs and that wonderful German industrial production. This is going to be an extraordinary experience where they're, quite frankly, they're really banking their future economic health on that strategy. So I would predict you will find some of the most innovative storage capacity technologies, grid, and use of renewables, and you'll see. Now, we don't know if the experiment will succeed or fail.
In fact, I think it's fair to say that in the short run, they're relying more heavily on
coal-fired and French nuclear, which is sort of ironic, but that's okay. It's a transition strategy. But again, watching how other, and obviously it's a smaller example, not to the U.S. strategy, but there is some great experimentation. And again, I'll put my Europe program hat on rather than the Arctic. You know, for Europe really does view climate change as a national security imperative. We do not have the same sense here in the U.S. And they've really done some experimentation, whether you support it or not, but emissions trading schemes, which have been very challenged, but they are experimenting. And I think there's a lot of transatlantic cooperation and sharing of best practices that we can both use. So I'll take my Europe program hat and put the Arctic
and let's take
one
another
back on.
question. Thank you.
Yeah, hi. My name's Robin Schaefer. I'm a former AAAS fellow and now an independent consultant. And I wanted to thank you all, first of all, for this wonderful discussion. I think Heather mentioned earlier some concerns about the contaminants that could be released as permafrost melts in Russia. Well, we know that there are several Superfund sites in Alaska, including in Chukchi and in Prudhomme Bay. So I'm wondering if you guys could tell us anything about what steps are being taken to protect us from, you know, what will happen as permafrost melts there, and also from the ExxonMobil perspective, if you guys have actually learned from what happened in these earlier periods of oil exploration, right, which is the source of these Superfund sites.
I'm not as familiar with the Superfund sites, other than the Department of Energy has been working in Alaska for many, many years. I think, again, watching experimentation, we will see, I think, not the best practices that we would want to see in how Russia will be handling this increase in toxins and things that have been environmental degradation in the Russian Arctic. In fact, I would probably make a case if the Russian government would allow it, that we need to have a lot of cooperation in helping Russia deal with this environmental challenges in the Arctic, because they're not putting the focus on it, I think, as they should. But again, this is, for me, Arctic policy, it's testing all of your assumptions. Everything that you thought, well, this is how this works, you need to just turn it upside down and make an assumption of how it's not going to work, whether that's sort of sea ice and things like that, and make sure you have built in a lot of redundancies and a lot of very precautionary, I would call it paranoid policy, in making sure that we have those redundancies. When these events that are going to happen, are we fully prepared for them? And I think it's an excellent question, and I know that the Russian case is a more exaggerated case. I'm just not as familiar with the Superfund process in Alaska.
Do you know anything about that, Jed? The Superfund sites up there?
I don't know for sure what she's referring to. Certainly,
Like the BP exploration sites.
no,
That are Superfund sites.
from
BP in Prudhoe Bay are now considered Superfund sites. She
yeah,
says.
well, certainly, all oil and gas companies have instituted operations integrity management systems, and our own started after the Valdez spill to really put a tremendous amount of focus on zero accidents, zero spills, and quality risk management. So our emphasis is significant on the prevention end, and the precautions we take in drilling now are significantly more involved and in-depth and improvements over, say, what we did several decades ago. And if you look at what Shell did this summer, they, beyond the regulations which required them to have ability for same-season relief well, they also brought a capping stack, and they also brought an oil containment dome and storage facility, and 200 of the 2,000 people that they had on site were wholly devoted to oil spill response. So there is, and it's because you realize there can be company-ending type events where your reputation and financially you could be destroyed. There's a tremendous focus on risk management that I've seen grow over my 30-year career, and it's part of our culture. And I think that's the most significant preventer of things like that.
Yeah. Question from over here.
Sure. David Constable, independent consultant. I'd like to thank you all for great responses. Julian, this is mainly directed at you, but certainly others might have an opinion. About 5 or 6 years ago, I was involved in a panel for metrics for global climate change research. And one of the things that really impressed me was how much we didn't know. And Julian, I've heard you several times saying today, we really don't know. And so my question is twofold. How is the pipeline for bright young researchers to try and answer those questions? And two, one of the things that impressed me at the time 6 years ago is that the research infrastructure wasn't really in great shape. So have we improved that research infrastructure, and how are we poised to answer some of these questions that have been raised tonight?
Well, I guess I would say that in general, I think the funding for climate science is going down. I mean, there's a lot less money available for climate science, and that seems to have been the trend. I mean, in some ways, us working in the Arctic, we're a little bit more lucky than some of the other disciplines because there's a lot of interest now in the Arctic as the sea ice has been showing such a strong rate of decline in the last few years. So there is a little bit more research money in my discipline, but in general, overall, the money for science is going down, and there's a lot more graduate students coming up that are looking for funding, and we can't always give them funding. I think the competition for getting the little bit of money that's out there is increasing, and in some ways I would say it's not that encouraging to encourage PhD students to come out right now because there isn't a whole lot of money right now out there for science, and that's really unfortunate. I would hope that would change as our government starts to realize more the importance of climate science and trying to understand impacts of things like the Arctic sea ice disappearing and what we need to be doing to be ready to respond to different situations, especially with industry getting more active in the Arctic. But I haven't seen that happening lately.
Maybe you could say a word or two about the satellite problems we're having. I mean, the Earth observing satellites are in distress, and I think that's another that I wonder if that's going to impact your work.
Well, I mean, yeah, I work a lot with satellite data, and what we're finding is that we're having to rely more on other countries for satellite data. The Europeans are still putting up a lot more satellite programs than the U.S. is. There's been big cuts in the satellite program for the U.S., and a lot of missions have been scrapped. And that is definitely a concern for a lot of us. I mean, some of the programs are still going through, and some of the ones focused on the Arctic are still going to probably go through, but a lot of the other disciplines are hurting worse than we are.
And the ice, and wasn't one of the ice satellites, didn't that end up not working as expected, and there's sort of a ice bridge program to sort of by aircraft to sort of plug some data gaps and stuff?
There's a gap from the U.S. had ISAT-1 was their first sort of laser altimeter to map how thick the ice sheets are, how thick the sea ice is. And that sensor actually worked pretty well, but there were some failures on it, and it quit working in 2009, in the spring of 2009. And the next ISAT-2 won't be launched probably until maybe 2015, maybe beyond that. And so in the meantime, NASA's been doing this huge aircraft campaign to fly over the Arctic and the Antarctic to do some sort of in-between mapping between the two satellite campaigns. You also have the Europeans just launched Cryosat-2, which is now providing some good data as well. And together with the US satellite, when that goes up, will actually give us even more information than we currently have about how the ice is changing on the planet. But yeah, that's been certainly a big concern of ours, is that the satellite programs are getting scrapped, a lot of the ones that we would rely on for our data.
And there's real trouble, probably more with weather. Some of the polar orbiting weather satellites, I guess, had significant delays, and they're looking at data gaps down the line for that as well, which is a little bit spooky.
Yeah.
So,
I mean, luckily the Europeans are still continuing some of their programs. So.
Yeah, but we want our satellites. We want our data. It's in inches and feet instead of all these metric things.
I to piggyback on Julianne, I mean, it's not only just the importance of the science, but the science has to inform the ultimate policy. And I think there's a real silo in our government system that the science is wonderful, but it sometimes doesn't always cross over into shaping and informing policy. And I think, as we've talked about here, you're going to see the Arctic as a public-private partnership, where the private sector is going to have to join with the government in trying to understand this. And there's a huge layer of international cooperation, because we all can't, unfortunately, Richard, we all can't afford our own satellites. And how do we share data? Russians have a satellite GLONASS that's extremely good at high altitudes. How do we all work together on that? We just don't have, right now, we don't have the financial luxury of doing this. I'm reminded of the Winston Churchill quote, at least he was attributed, and he said, "Gentlemen, the money has run out. It is now time to think." And I sort of feel like we're getting to that point of we now really have to think, because the money is not necessarily, we're going to be in a budget constrained environment, and we really do have to think how to do this in a smart way.
Yeah, I think we have time for one last question.
Hi, my name is Pramukta Kumar. I'm almost a physicist at Georgetown, and coincidentally, I have a related question. Obviously, developing the Arctic requires a lot of basic research into science, technology, and perspective. And with those shrinking budgets, a lot of that responsibility is now shifting to private companies, such as ExxonMobil, that does fund quite a bit. How does that overlapping interest shape the discussion between academia, the corporate sector, and the government?
Well, we have been conducting Arctic research at ExxonMobil now continuously for 30 plus years. Most of that is on sea ice properties and loads and how to build infrastructure. And we more recently have been focused on Arctic characterization. We're large consumers of satellite data ourselves. And someone asked about the availability of young scientists. A few years ago, I was recruiting heavily in Russia to try to find good Arctic engineers, because the United States doesn't produce very many. We recently made a job offer to one of your ice observing PhDs, but I think he took a job somewhere else. But they are hard to come by, and so we looked to Russia, and we've had several decades now of a continuing relationship with the Arctic and Antarctic Research Institute there, who are some of the premier Arctic researchers, and they don't have large budgets, so we've done a lot of work with them to continue to sustain that level of expertise that we knew we would need. Same with the Earth Cryosphere Institute in Moscow, who are the permafrost experts. So, the industry is shouldering a lot of the responsibility for making sure that the science is there, because we want to be very cautious, and mainly, as Rex Tillerson says, we are risk managers, and we have to fully understand the science before we do anything. And when it's not available externally, then we build it ourselves.
So I know that industry collects a lot of data out there when they're working in the Arctic. Is any of that data available to be shared with other scientists that are working with the government? I'm curious about that, because I know that there is a lot of data being collected by industry.
Yeah, some data are. For instance, we did a program in the Fram Strait in 2009 with the Odin and the Finnica. Those data are still proprietary, but there are other data, like we just did an iceberg subwater line profiling study and off the coast of Newfoundland, and those data are going to be public, because it kind of lifts all boats from a safety perspective. We do gather a lot of ice drift, acoustic Doppler current profiler and ice profiling survey data, but our biggest source of that's government data, like Humphrey Melling's data from Canada. Likewise with satellite imagery, we like to use as much of the government available, purchase that data as we can, and only when we need it do we order specific high-res images, and like everybody else, we generally keep those.
Yeah,
but that's not a large quantity of high-res imagery.
Now, there's been some discussion at some of our meetings where we've talked about wanting to have more collaboration between industry and scientists in terms of trying to better understand what's going on in the Arctic. And I realize that industry is very active up in the Arctic, and they are collecting some really good data. And just wondering about the collaboration potentials that industry and...
Yeah, and some of it is we don't always publish in the same literature. For instance, we've been the last few seasons up on the Amundsen. That's a Canadian icebreaker up off Banks Island, collecting data on ice drift and the condition of multi-year ice. Most of that we've published, but we've published a lot of it in the sort of industry literature. And we have a new model for sea ice drift forecasting that we're actually going to publish next in Geophysical Research Letters, where Julian publishes regularly. So sometimes it's just we're not looking in the same literature.
Yeah. Well, sounds like you should exchange business cards here. So, great. We are out of time, but I thank you all for your attention. It was lots of great questions. Thank you very much.
Before everyone leaves, I'd also like us all to thank Richard Harris for being such an amazing moderator. I'm Joanne Carney with AAAS, and on behalf of my organization and as well as the American Chemical Society and Georgetown University, I'd like to thank you all for sharing this evening with us. And Richard, I don't know if you can scroll back the other direction. For some reason, I can't do it from here. Oh, there we go. Okay. So if you would like to see archives of this session, it will be posted soon on the website of the American Chemical Society. You see the URL here on your left, and there are also archives of the previous sessions that we had in this past in October on biosecurity and on the Nexus, Energy and Water Nexus, as well as archives of past lectures over the last few years. So thank you again for sharing this evening, and we look forward to seeing you all next year when we launch our series in the fall for the 2013 series. Thanks again.
The Arctic is, and to his left is Heather Connolly, who is the director and a senior fellow at the Europe program at the Center for Strategic and International Studies, and she's obviously the policy person we'll pick on for some of the policy questions and so on. So the question really is, what's going on up there? It's a part of the world that until a few years ago we weren't thinking about, most of us. Probably most of us still aren't, but things are afoot up there. I just read that there was a liquid natural gas tanker that went from Norway to Japan through the Arctic Ocean in November. It's like, hello? Isn't that white stuff ice? So at any rate, things are changing up there rapidly. And the question is, what are the implications for global conflict, for resource development, et cetera, et cetera? So we're gonna poke and prod at that question during this conversation. And I want to start with Julianne, first of all, and say, what is going on up there? Let's start with the natural world up there. What's happening with that ice?
Well, there's several profound changes happening in the Arctic, and certainly what's become basically the poster child for climate change is the decline of the Arctic sea ice. And we have about 60 years now of pretty reliable data, a little bit more than 30 years of satellite data, but we also have earlier observations from ship reports and aircraft. So we can kind of go back to about 1953 pretty reliably. And during that time, we've seen the Arctic summer ice cover is shrinking quite dramatically. And it's been sort of this linear rate of decline, but in the last few years, it's accelerated quite a bit. And it's been taking a lot of us by surprise because the changes that we're seeing in the summer ice cover are definitely outpacing a lot of what sort of our worst case climate models have been suggesting would be happening at the Arctic as we continue to warm the planet. And so these changes are happening a lot faster than we expected. And it certainly is, there's a lot of implications for that, definitely with governance and certainly exploration, because these regions of the Arctic that before were always covered by ice year-round are actually now opening up for quite a few months during the summertime. And when you look at a lot of our climate model simulations and you increase amounts of atmospheric greenhouse gases in the atmosphere, every one of those climate models suggests that as we keep doing that, the Arctic Ocean will become ice-free. And some of these models suggest it may happen as early as 2050, some of them sometime after 2100.
2015 or 50?
2050.
50.
Although I have to say there are some models that suggest it could happen as early as 2020. But when we compare the observations to a lot of these climate model simulations, we find that on average the models are still lagging the observations. And so we're probably about 20 to 30 years ahead of what a lot of the models are showing us as to when this might happen.
Yeah, and this was a banner year, for melt. But let's distinguish between summer ice and winter ice, because it's not going to be open,
right,
wide open year round. There's a natural cycle that is, I guess, gone on for a long time, right? It grows in the winter and shrinks in the summer, right?
Right, and so what we really talk about when we talk about ice-free Arctic, it's really ice-free in the summers because it's still going to get cold enough for quite some time for the winter ice cover to come back every year. And the changes in the winter ice cover are pretty small. There's definitely some more open water that we're seeing in sort of the eastern Arctic, the Kara and the Barents Seas. But most of the Arctic is still covered by sea ice in the wintertime. So we're really talking about the summer ice cover and opening up the regions off the coast of Alaska and Siberia that are now becoming ice-free.
So these used to be sort of permanently covered in ice?
Right.
Potentially moving to what we call deeper water, which for the Gulf of Mexico would be 400 plus meters, but in the Arctic, because of the ice loads, you get to a deep water transition at about 100 meters, where if you're going to put any kind of facility out there, it has to be floating versus bottom founded because of the ice. And there's probably not a lot of conflict over that whole middle part of the Arctic Ocean because that abyssal plain has very thin sediment cover, and at least from a hydrocarbon perspective, it wouldn't support any oil or gas. So once you get too far off the shelf there, it's pretty barren.
I see. Yeah, I want to talk about the shelf because there's some weird politics and so on with the fact that there's the 200-mile zone limit and so on we can do with that. But I guess in terms of oil exploration up there, I mean, Shell says, well, it's at least where they're drilling in the Beaufort and Chukchi. You want to show people where those are? Yeah. They say, it's second only to the Gulf of Mexico. And some people say, well, why not go to the Gulf of Mexico Beaufort, where you can... That's the Chukchi is closer to Russia than the Beaufort's a little bit.
They're over here, and Beaufort, they're here.
Yeah.
Both of those are in less than 100-meter water depth.
Yeah, but I guess the question is, why so much interest up there? I mean, are we really running that low of resources in places that are easier to get to, easier to cope with if there's a spill and so on?
Yeah, well, a lot of people reckon that by 2030, the current demand for hydrocarbons will have increased by 50%, with hundreds of millions of people in countries like India and China just now becoming large energy consumers. And when you look at the suite of opportunities around the world for trying to meet those energy demands, it's going to take everything that's available. And the Arctic is one component of that. The USGS has reckoned that about a quarter of the remaining undiscovered hydrocarbon potential of the Earth lies in the Arctic. Albeit, if you look at those 400 discoveries, it follows a pretty similar trend even as you move up in reservoir size, that about 80% of those are gas and about 20% oil. Of course, Prudhoe Bay, the largest discovery in the United States, in North America, is located in the Arctic at 13 billion barrels recoverable. But the Arctic appears to be largely gas, and that gas is going to be challenged to come to market in the near term. So what we're
because
really
of cheap prices and it's hard to move stuff around, right? Both reasons, yeah.
Yeah. Well, logistically, the Arctic's very challenged, but it is a possible player and will be a player in supplying world energy demand, and it will come on as market and price conditions and our ability to do it technically come on.
Yeah, so Julian, let me ask you, how much is the ice going to cooperate with this? I mean, this year we saw it was the lowest ice in the satellite record, really incredibly low ice, but Shell was saying, we can't go in when we want to because there's ice here. It seems it was perhaps a little bit of irony that they were having trouble, among other reasons.
Good evening, and welcome back for the final 2012 installment of Science and Society Global Challenges. My name is Pete Folger. I'm with Georgetown University. And this program of moderator-led policy discussions uses neither PowerPoint nor notes, and is sponsored by the Georgetown University Science in the Public Interest Program, the American Association for the Advancement of Science, and the American Chemical Society. And we also warmly thank ExxonMobil for their continued support. Now, I mentioned no notes and no PowerPoint. I have notes, and there actually will be a couple PowerPoint slides, but the organizers take the blame for that. Don't blame our panelists and our moderator. They'll remain pure. So I'm pleased to introduce tonight's discussion. It was originally scheduled, as you may know, for October 29th, but was delayed due to the arrival of Hurricane Sandy. Tonight's discussion is called Climate Change, the Arctic as an Emerging Market. And our panelists are Julianne Struve, Jed Hamilton, and Heather Connolly. Moderating the discussion is Richard Harris, who brings his crack NPR journalism skills and direct experience in this venue, and including our most recent discussion a couple of months ago in October on the energy, water, food nexus that some of you may have come to. Now, without further delay, although I want you to turn off your cell phones or mute them, and unless we're hit by a derecho, I think we're ready to go. Richard.
Thank you very much. Welcome, one and all. We actually only have, was this a PDF or a PowerPoint? We said bring a PDF, right? So we would not violate the no PowerPoint rule, and we only have one of them. But this is, I think this will help us stay oriented throughout the day and or evening. And let me give you just a sense of what's going on. We're going to talk. I'm going to try not to talk too much. I love this topic. I could spend all hour and a half just peppering these folks with questions. But what I'd like to do is get the ball rolling with some questions to sort of set the stage. And about maybe 45 minutes in or so, then I will open it up for questions from the audience. We have a couple of microphones, and you can come to those. I sort of think of this as a slightly elongated play EP Talk of the Nation kind of format, where you can be the callers, and I'll be Neil Conan or Ira Flato, depending upon the day of the week, and we will at any rate we'll just have a lively conversation here, and looking forward to the evening. And I got to also keep track of time because I know this one's going to whiz by. But let me make some very brief introductions. Julianne Struve, right, is from National Snow and Ice Data Center and you're a research scientist there. That's up at the University of Colorado in Boulder. But it's this own sort of separate thing. If you ever want to find out about Arctic ice and you don't know about NSIDC already, it's a great website to go to. You can see just how badly it's melting at any given moment of the day, any day of the year, and it's a wonderful resource for keeping track of the Arctic ice. To her left is Jed Hamilton, who's a or the senior Arctic consultant. the senior Arctic. You could have had somebody who started exactly the same day, but he's at ExxonMobil Upstream Research Company, and this is about as upstream as you can get, I think.
Arctic, if anything, I would argue we don't have enough capability, search and rescue, icebreakers, because all of this commercial activity, all the wonderful tourists who want to go to the North Pole, they're going to need to be rescued. But we don't have the ability to rescue them right now. And my quiz is, okay, everyone, how many icebreakers are in the United States Coast Guard fleet today?
I know.
How many? That's right. You got one, and you better hope it's in the right place at the right time when you need it. So this is about developing the U.S. infrastructure, but also working very cooperatively with our partners.
Yeah. And Jed, I mean, there's another simple storyline that is I'm sure not entirely true, which is that the ice is melting and all of a sudden there's a big oil rush up there. And Shell, of course, we've heard a lot about their efforts this summer to get a foothold in the Arctic, and it's being portrayed as a brand new thing that hasn't happened before, and so on. Put that in context for us. How new is this?
Okay, Richard. Yeah. Well, the industry has been working in Arctic-like conditions since about the 1930s, when ExxonMobil started developing the Norman Wells field, which is 1 degree south of the Arctic Circle in Canada. And we put the first offshore platforms in a significant sea ice environment in Cook Inlet in the mid-60s.
Hold on, let's do a little geography here. Cook Inlet is down.
Yes, it's still what we would call, it's below
it's right here, right?
Yes.
So that's sort of out of the Arctic, but it's in cold water and it ices up, right?
Yes, and it's got high tidal current, so it was fast moving and fairly thick first year ice. And we moved through the 70s and 80s with exploration in the U.S. and Canadian Beaufort with a number of gravel islands. All the development there has been from shallow water islands, nothing exceeding really about 20 meters water depth.
So you pile, if you want to go drill offshore, you sort of build an island out of gravel and then you can use
right,
that as
and those are able to sustain the ice loads without a problem. There have been about 412 discoveries north of the Arctic Circle, and there are quite a bit, has been quite a bit of oil and gas development. Of course, one of the most prolific areas north of the Arctic Circle is the Yamal Peninsula in Russia. Let's see if you can find Yamal. It's over here.
Here, let me give you the pointer. I knew I was going to get in trouble very quickly with the geography.
This is the Yamal Peninsula here, where a lot of the gas that supplies Europe comes from. And recently, ExxonMobil signed a joint venture agreement with Rosneft to develop 3 blocks in the Kara Sea, which is right here between the Yamal and this island called Novaya Zemlya. And those 3 blocks are on the order of the size of the entire productive portion of the Gulf of Mexico. So the industry has a long experience with development in Arctic conditions, both onshore and offshore. ExxonMobil and Shell both developed off the coast of Sakhalin, and up to 2 meter thick first year ice, but again, it's subarctic. So now what the industry is looking at is...
Yeah. Wow, so big changes. So let's turn to the geopolitical implications of this, Heather. I mean, what was it, 2007, the Russians made a big deal of planting a flag in the middle of the Arctic Ocean, and it seemed as though everyone pulled out their pens and started writing stories about conflict over in the far north. Should we be worried?
Well, you know, the Arctic has always been very important geostrategically to us. Recall in World War II, it's vital supply lines to the Soviets in the Eastern Front. Then during the Cold War, strategic bombers flew over the ice, nuclear subs under the ice. It's always been strategic. The U.S. missile defense architecture is in the Arctic, whether that's from Fort Greely, Alaska, through Thule, Greenland. The Russian strategic nuclear forces, their northern fleet, is in the Arctic. So it's always had a great deal of geostrategic importance to the world. But after the collapse of the Soviet Union, things sort of, the relationship thawed a little bit. and it became much more an area of opportunity and collaboration. And in 1996, a new organization was formed called the Arctic Council. And it brought together 8 member states, the 5 coastal states, the US, Canada, Denmark via Greenland, Norway and Russia, plus 3 other almost the coastal states, but not quite, Finland, Sweden, and Iceland. But most importantly, it brought the indigenous peoples together at the table, the permanent participants. And since 1996, that's been the primary vehicle for how we've collaborated and cooperated regionally about the Arctic. But as we're seeing the rapid thawing, other non-Arctic states are becoming very, very interested in what's going on in the Arctic. And not only this summer did we see a gas condensate go from Hammerfest, Norway to Japan, we saw a Chinese icebreaker come through the Northern Sea route. And here's your quiz. What's the largest diplomatic embassy in Iceland? China has the largest diplomatic. You're like, why would China be in Iceland? Well, a lot of rare earth minerals. They understand the strategic implications of a shortened shipping route from Asia to the west. So this is now becoming a really hot topic geoeconomically because of the fishing, because of the mineral resources, the natural resources. Ted will talk a little bit about that. And so all of a sudden, there's a global interest around the Arctic. But then I'll give you another little quiz.
Well, let me ask you about the original question was about conflict. Let's sort of set the stage here a little bit. Should we be worried about conflict? We could talk about some of the other stuff a little bit later in, but
no. This is our Norwegian friends who call the Arctic the High North. They say this is high north, low tension. That we aren't seeing great tension. In fact, we're seeing 2 years ago, Norway and Russia, after 40 years, agreed on their border in the Arctic. We're seeing where cooperation between nations on search and rescue, oil spill and response, they're trying to address the transformation. So I've disappointed many journalists, Richard, when I've said we're not seeing the militarization of the